Okay, here's some more problems from the related rates worksheet, or example problems, I should say, to help you with those. This is number 17 through 20, so this is the ladder problem, kind of a classical problem in related rates. A ladder 14 meters tall leans against a vertical wall of a house. The bottom of the ladder is pulled away horizontally from the house at a rate of 2.5 meters per second. How fast is the top of the ladder sliding down the wall when the top of the ladder is 5 meters up the wall? So I drew a sketch here. And we're given that this is the ladder, and this is the vertical, and this would be the horizontal. These are changing, so we're using variables because as the ladder slides down the wall, you see that it would move down. As this is pulled away, as the base of the ladder is pulled away from the wall at 2.5 meters per second, then the base is over here, and the top of the ladder is over here, and it slides down and down and down. So you can see that. So this is vertical Y, this is horizontal X, and these are changing. So these are variables. This is not changing because the ladder is always 14 feet. That's not going to change. So these are variables. That's a constant. And then we wrote down the data that we had, and that the horizontal movement or position is changing at a rate of 2.5 meters per second this way. We want to find how fast it's moving, sliding down the wall. So that'd be the dy dt. And that would be when y equals 5 when it's 5 meters up the wall. Now, I did do some variations on these, so you might have noticed it. Instead of saying when the ladder is so many meters up the wall, I said when the bottom of the ladder is so many feet from the base of the wall. So in that case, we're giving you an x. So read those carefully, because if we say when the bottom of the ladder is so many feet from the base of the wall, we are telling you the x, and then you still have to figure out the y. So here we have the y. We're eventually going to have to figure out the x that goes with it. Some cases I give you the x and you have to figure out the y that goes with it. So read it carefully and watch the variations on those. Okay, so we've got our dx dt. We're looking for dy dt. So we better first of all find some kind of relationship so we can model these again with the Pythagorean theorem. And we can say that x squared plus y squared equals 14 squared. And then we'll take the derivative to get our differentials in there. So that's going to be 2x dx dt. Again, we're doing this with respect to t implicitly and then using the chain rule. Plus 2y dy dt equals, and the derivative of 14 squared, that's 196, is 0. It's just a constant. And we're trying to solve for dy dt, so I'll subtract this term from both sides. So I have 2y dy dt equals negative 2x dx dt. Will be negative because it's going down the wall. And if I divide both sides by 2y, I have dy dt equals negative 2x all over 2y dx dt. All right? And then we know that dy dt equals just negative x over y dx dt. And then we just substitute in, so we'll move over here, give us a little more room. Dy dt equals negative. And then what's my x? I don't know what my x is. What's my y? My y is going to be 5. And my dx dt is 2.5 meters per second. So now I got to figure out what the x is, and again we'll draw a triangle. Now remember, if we gave you the x, you'd find the y. So the same idea. Just have to make sure that you put them in the right place here. So I'll draw a right triangle because I know again these numbers are always in this Pythagorean relationship. So at that moment the ladder is again 14, and at that moment the y is 5. So we want to find out what x is. So we know that 5 squared plus x squared equals 14 squared. This is 25 plus x squared equals 196. And if I subtract 25 from both sides, x squared equals Yeah, this doesn't look very like a nice number, does it? Okay, let's double check that. 25, that's going to be 6, 9, and 1. So x equals the square root of 171. And then we got this little trick. If we add up these digits, 1 plus 7 plus 1, that adds up to be 9. So that means 9 goes in there, believe it or not. So x equals the square root. Again, 1 plus 7 plus 1 is 9. That number is divisible by 9, so that means 9 must go in there. So let's divide this. And 9 goes into 17 once. Remainder 8, and 9 goes into 81 9 times, and 9 is 81. So x equals 3 times the square root of 19. All right, so that goes here. And then we can multiply these out. Sometimes we don't like a decimal, so we can multiply the top and the bottom here by 10. And that'll help us simplify it a little bit easier. So we could say that this equals negative 3 times the square root of 19. And if I multiply this by 10, I get 25. And if I multiply the bottom by 10, I get 50. So I'll multiply that by 10 and that by 10, and then 25 over 50, just 25 goes into 50 twice. So that makes it nice, so that means my dy dt equals negative 3 times the square root of 19 all over 2, and that would be meters per second. No calculator, so you just leave it in radical form. So again, when you have a decimal, we don't like decimals and fractions, so we usually multiply the top and the bottom by some power of 10 to remove the decimal places, and then we can usually simplify. Okay, so there you go. There's your answer. So try to think about these problems, make sure they make sense, and then you shouldn't have to have any trouble doing 17 through 20 on the worksheet. Make sure though that you do watch out, did we give you y or do we give you x? Because I do kind of change those up a little bit.